Today, we're going to learn about polygons. We see a variety of shapes around us. Some of these are represented here. Can you tell me which of these figures are closed figures? Think a little. Let me explain this. By looking at these figures, the first thing we observe is that some of these are made of closed curves, while some are made from open curves. If we focus only on closed figures, then there is an interesting point for these. Among these figures, some are made of line segments only, whereas some are not made of line segments. They are made up of curved lines which are not straight. We call figures made of line segments as polygons. If we break the word polygon, we get two words, poly and gon. Poly means many and gon means sides or angles, which means a figure that has many sides is called a polygon. Now assume you've been given a pencil. Will you be able to make a polygon out of that without breaking it? Think a little. No, because a line segment cannot form a closed figure. Similarly, if we take two pencils and try to make a polygon out of them, then again we will not get a closed figure or a polygon. But if we take three pencils, then we can definitely make a polygon. Similarly, we can make polygons from 4, 5, 6, etc. pencils. In this way, we can say that 3 or more than 3 line segments are necessary to draw a polygon. Such line segments which form a polygon are called sides of polygon. Therefore, a polygon has 3 or more than 3 sides. The point at which any two sides of a polygon meet is known as a vertex of the polygon. Here, we will name the vertex as A. Similarly, we can name the other vertices also. In this way, we can say that this polygon has 4 sides, which are sides AB, side BC, side CD, and side DA. We can name a polygon with the help of its vertices. Like here, we will name it as polygon ABCD. While naming a polygon, remember that we start from one point and move to the other subsequent point in an order on the boundary of the polygon. This order can be in either clockwise or anti-clockwise direction. Like this, we can name a polygon ABCD or polygon BCDA or polygon CDAB, but we cannot name this polygon as ABDC because points ABDC are not in sequence on the boundary of the polygon. Now let's talk about side AB and side BC. Both these sides are meeting at one point only. This means for side AB and side BC, point B is the common point. Any two sides having a common endpoint is known as adjacent sides of a polygon. Therefore, here sides AB and side BC are adjacent sides to each other. So, can you tell me which are the sides adjacent to CD? Think. Absolutely correct. Since D is common in sides CD and DA and C is common in sides CD and BC, therefore, DA and BC are adjacent sides of CD. Now observe side AB. This side has two endpoints, point A and point B. The endpoints of the same side of a polygon are called adjacent vertices. Therefore, point A and point B are adjacent vertices. Similarly, point A and point D are adjacent vertices. But point B and point D are not adjacent vertices. Can you tell me the reason for this? Absolutely true. The reason behind this is point B and point D are not the endpoints of a single side. If we connect such vertices which are not adjacent, then the line segment so formed is called diagonal of the polygon. Like here, line segments BD is the diagonal of the polygon. Similarly, if we connect A and C, then we get the diagonal AC. In this way, you must have understood a lot about the concepts of polygons. Today, we have learnt about polygons. In the next video, we will see some interesting examples of this. Today, we are going to see some examples of polygons. Which of the following figures are polygons? We are expected to identify polygons among the given figures. Can you tell on which basis we will identify whether a given figure is a polygon or not? Think a little. Let me explain this. As you know, a closed figure made of line segments is called a polygon. On this basis, we can say that a closed figure is a polygon if all its sides are line segments. Here we see that figures C, E, H, J, and K are not completely made of line segments, rather these are made with curved lines. Similarly, figure F and G are made of line segments, but these are not closed figures. Hence, all these figures C, E, H, J, K, F, G are not polygons. If we observe A, B, D, I, and L, then these are made of line segments and are closed figures. Therefore, in the given figures, figures A, B, D, I, and L are polygons. Observe figure I carefully. Though this appears as an open figure to us, but if we start from one point and continue to move on its boundary, then we observe that we reach the same point from where we started. Therefore, it is proved that this is a closed figure indeed. Next example. Solve the following puzzle. I am a polygon which lacks a diagonal. Tell me how many sides are necessary to form me. Such an interesting puzzle. We need to draw such a polygon which does not have a diagonal in it. The number of sides of this polygon will be the answer of the puzzle. So let's solve this puzzle. As you know, a polygon is a closed figure made of line segments. The line segments from which the polygon is made are called sides of the polygon. You also know that at least 3 sides are compulsory to form a polygon. Let's draw some polygons. This is a polygon with 3 sides. This is a polygon with 4 sides, and this one has 5 sides. Let's talk about the polygon with 4 sides. If we connect such vertices which are not adjacent, then we get a diagonal. In a 4-sided polygon, we can draw 2 diagonals. Similarly, in a 5-sided polygon, we can draw 5 diagonals. Can you tell me how many diagonals can be made in a 3-sided polygon? Think a little. Absolutely correct. This has no diagonal. Hence, this is the polygon represented in the puzzle. Since this is made of 3 sides, the answer to the puzzle is 3. Next example. Construct a polygon PQRSTUV and identify its adjacent sides. Here, we have been given a name of a polygon. Let's use this to construct the polygon. Can you tell me how you would do this with the name? Think a little. Let me explain this. Each letter in a name represents a vertex. Since there are 7 letters, therefore, we can say that the polygon will have 7 vertices. So let's represent 7 vertices of a polygon with 7 points. But while doing so, be careful about the sequence of the vertices. Now if we connect the vertices, then we get the polygon PQRSTUV. Since here no condition is given for constructing a polygon, we can construct it in different ways. Pause the video and think about it. Now let's find adjacent sides in a polygon. As you know, the two sides having a common endpoint are called adjacent sides. In this way, adjacent sides in polygon PQRSTUV are PQ and QR, QR and RS, RS and ST, ST and TU, TU and UV, UV and VP, and VP and PQ. Just think, if we are given conditions such as length of sides and angles should be equal, then it was necessary for us to construct the polygon with given conditions. In that case, only this figure would have been correct. Now solve this question by yourself. Draw a polygon with 6 sides and identify how many diagonals can be drawn in this. So today, we have seen examples on polygons. In the next video, we are going to see misconceptions related to polygons. Today, we are going to see some misconceptions and one common mistake related to polygons. Misconception 1. Identify the polygon in the figures given below. Many students do not understand the concept of polygons correctly. They think that since all these shapes are closed figures, they are all polygons. So they give the answer as option 1, which is the wrong answer. Some students think that only large shapes or figures can be polygons. Since figure Q appears smaller, that is why they don't consider this as a polygon. They consider P, R and S as polygons and give answer as option 2, which is the wrong answer. Correct understanding is that a polygon is a closed figure made of line segments. In the figures given, P, Q and R are made of line segments, therefore they are polygons. But figure S is not completely made of line segments, therefore it is not a polygon. Hence, in the given figure only P, Q and R are polygons. Therefore, the correct answer of the given question is option 3. Misconception 2. Identify the incorrect name of polygon from the options given below. Some students have a misconception that the name of the polygon can be identified by writing the letters of the vertices in any order. In the given figure, vertices are named from A to F. Students ignore the sequence in vertices and name the polygon as A, B, C, D, E, F, which is a wrong name. Therefore, option 1 is the correct answer to the given question. Some students understand that naming the polygon starts from the left side only. Therefore, they think that the name of the polygon will start from either F or A and not from D. Therefore, they think that the name given in option 3 is incorrect. Hence, they give the answer as option 3. But this is a wrong answer. The correct understanding is that we can name a polygon with the help of vertices. While naming, we can start from any vertex and progressing in one direction on the boundary. Write the vertices in sequence one after the other. In this way, the name of the given polygon can either be FECDBA or DCEFAB. Both ways are correct. Therefore, option 2 and option 3 are correct names. Hence, they cannot be the answer to the given question. Now let's see a common mistake. Observe this polygon. Is line segment BD a diagonal of this polygon? Think a little. Let me tell you, some students think that line segment BD is outside of polygon, therefore, it cannot be a diagonal. But this is a wrong understanding. The correct understanding is that if we connect two such vertices of a polygon which are not adjacent, then we get a diagonal. It is not necessary that diagonal should be present inside the figure only. It can be outside also. So today we saw some misconceptions and a common mistake related to polygons.